Hi everyone, I hope you're well. This is the overview for Lab 10. In this lab you have a single assignment, but it's a bit larger than the previous two labs because you're writing a program from scratch. And it refers to the patterns document. You'll find that, and the Lab 10 materials refer to the patterns document. That document's all the way at the top of the course in Canvas. It's right here. So I've downloaded it already, and we'll be taking a look at it momentarily. All right, so you're going to start a new program, name it Lab 10. And your program is going to have three parts. First, a part to do the frequency counts for the birth weights, where you'll have to clean the birth weight data, convert the pounds and ounces to ounces, and then update a frequency count. Then you'll define your function, percentile rank, and then finally use it 4 times. I'm going to lead you through an example program that shows how to clean these two fields and do the conversion. Rather than do frequency counts, I'm going to do a single sum and a single count to compute a mean. I'm going to ask you to then modify that in your program to do the frequency counts of the birth weights instead. So I'll draw comparisons between the pattern for frequency counts and this demonstration program, showing you where you make the changes, and then ask you to make those changes. Okay, let's review the patterns. All right, so we're working with the NSFG data. All right, so we need these two Python statements to start. All right, let's start with that. All right, new program. And let me save it right away. Lab 10. .py. All right. Import NSFG and get the data. Okay, so I'm going to do a mean of the cleaned birth weights. So I'm doing a sum and a count. What do I initialize count to? That's right, 0. Same with sum. Okay, so now we're doing counting and summation that we've done before. So I need a for loop to examine each record. Now here's where the cleaning comes in. So let's go back to the lab and look at the field information. Let's start with birth weight and pound. the values that we want to work with are those between 0 and 95. So if 0 less than equal item dot birth WGT underscore LB less than equal 95. Note carefully the spelling here. It's WGT underscore lowercase l. That's not a 1, that's an L. It's a common error to mistype this, so be careful with this. So we're doing a nested conditional. Next, we want to clean the birth weight in ounces, and the values we want to work with are between 0 and 15. Right. Now we're going to convert pounds and ounces to ounces. Okay. So I'll just name the variable weight. So it's 16 times item birth weight in pounds plus, right, this converts pounds to ounces, plus the value in the birth weight ounces field. Okay, now it's time to increase the count by 1. And then add the weight to the sum. Okay, so that's all the code for the for loop. Now, after we've done the for loop, we want to compute the mean. All right, so I unindent all the way back to here, so that this line of code, remember, gets run after the for loop completes. Mean equal sum divided by count. Okay, let's convert this back to pounds and ounces. All right, so pounds equals the mean divided by 16. This is a whole number division. Ounces equals mean remainder 16. All right, let's print that. Mean birth weight. That will be pounds. Give that a label, LBS, comma, and a comma to separate the next input, the print, and then ounces. Okay. Let's see, we have a warning here. What did I forget here? That's right, item dot. Don't be like me, don't forget that. Let's run this and see what happens. Okay, that looks about right. I don't like these decimal values. So I can clean that up a bit. Mean here is a decimal number. So I want just the whole number part. So int is what in computer science we call whole numbers. So I'm converting these values to whole number values by using the int conversion. All right, that's better. Okay. What you'll need to do, let me get rid of the parts of this that really aren't necessary at this point. Here's the gist of it. You want to modify this to do the frequency counts of the converted weight. So let's go back to the patterns document and look at frequency counts. Okay. You first need to create an empty dictionary. You can keep the name as counts if it makes more sense. Name it weights. So this will replace these two lines of code. And in your for loop, remember that this is the line of code that increases one of the frequency counts. Now, if you name your dictionary weights instead of counts, of course, you'll have to use weights here and weights here. And what do you use for value? That'll be the converted weight. Okay, so this line of code in the pattern will replace these two lines of code. Okay, so this line will remain the same. The two cleaning lines will remain the same. The conversion line will remain the same. You're just going to replace these two lines with the frequency counting line. And remember, use this to replace these two lines. Okay, the next part is a function. Okay, percentile rank. So you can start that next. Def percentile rank counts. And if you want to use weights here, again, you can do that. And the value. Okay. Counts is a set of frequency counts. Just like the frequency counts you've been using in the previous two labs. Value is going to be a weight in ounces. Let's fast forward a bit so that you can see that. Okay. So let's write a line of code that would generate this line of output if once the percentile rank function is completed. All right, so 4 pounds, 12 ounces. Print percentile rank. Oh, need a single quote. Percentile rank for pounds, 12 ounces. All right. Here's where you will use the function. And I'm going to assume that the name of the dictionary is counts. So plug that in. And then the second input is the weight in ounces. And I'm going to let Python do the work here. Right, because I need to convert 4 pounds, 12 ounces to ounces. So that's just 4 times 16 plus 12. Let's scroll this over. All right, I'm letting Python do the work. Otherwise, I'd have to go find a calculator. All right, so that's how you use the function. So you can see what values are getting plugged in for value here. And the 3 other uses of the function will be similar. Okay. In the function, let's go back to the one Socrative question and review what's going on when we compute the percentile rank. Okay. This Socrative question. Imagine that these are the weights, the birth weights, and this is how many babies were born weighing that much. The percentile rank 5 is the number of births at that weight, excuse me, at that weight or less. So 4 plus 7 plus 5 plus 2, 18, divided by the sum of all the weights. And then because we have a percentage, times 100. So the output line, all right, I'll make a comment. Counting code here. Right, because you'll have to compute a numerator and a denominator. And then your functional output, your numerator divided by your denominator times 100 to get a percentage. Okay, so let's talk about what's going on, what goes in here. You'll have 2 for loops, or 1 if it makes sense to you to do that. Similar to what you've done with the previous labs. Your denominator will be the sum of all the counts. Okay, where have you done that before? Prob and range. That denominator was the sum of all the frequency counts. Okay, so go back and look at your code for the code that you wrote for prob and range. The numerator is just the sum of the counts for the weight value or less. Right, so in this example, if we were doing percentile rank 5, the numerator is 2 plus 5 plus 7 plus 4. You did something similar. So this is the numerator. You did something similar for the denominator in conprob. Right there, remember, in the denominator, you took the sum of all the counts greater than or equal to that second input to the function. Here, for your numerator, you're going to want the sum of the counts less than or equal to the second input to the function. Okay, so that code will go there. All right, so that's the lab overview. Hopefully this gets you well started on the lab. If you have questions, post them in the Lab 10 discussion. If you get stuck, also check in on the Zoom class sessions. Or if you want some one-on-one help, shoot me an email and we can arrange a time to do that. All right, take care everyone. Be safe and be well.